Okay, today we're doing 4.6, which is graphs of other trigonometric functions. Mainly in this lesson, the two graphs we'll be looking at are the two we haven't seen, which are tangent and cotangent, which look quite different from the sine and cosine graphs, and there's a reason for that. It all has to do with tangents ratio being y over x. So let's go ahead and get started. When we do our tangent graph, we're going to be picking different angle values to develop the tangent graph than we did for sine and cosine. So the reason for this is because when we did sine and cosine, we initially picked quadrantal angles. So if you recall, quadrantal angles are these guys that land on the quadrants. And if they're landing on a quadrant, we use the unit circle to evaluate the tangent or the cotangent or the sine or the cosine. So there's those points. If I do the tangent of 0, and remember tangent is y over x, I get 0 over 1, which is 0. That's great. So tangent of 0, we actually are going to start with 0, is 0. And then if I were to do the next one, which is the tangent of pi over 2, and again that's y over x, I actually get 1 over 0, and that's not possible in math, and this is undefined. And so then if I go to the next one, which is pi, I'm going to get 0, and then I'm going to get undefined. So really I'm not getting very many values to help me graph this. So instead what I'm going to do is pick my 30, 60, 90 angles, and I'm going to write them in, and my 45, 45, 90s angles, and write them in radian form because that's the more common form. Pi over 6, if I do the tangent of pi over 6, we'll just draw that up here real quick. Just a little refresher. Here's pi over 6. It's a 30-degree reference angle, so opposite 30 is 1/2, root 3 over 2, 1. Y over x would be 1/2 over root 3 over 2. Copy dot flip, rationalize, that's root 3 over 3. And if I were to punch that into my calculator, that would be about 0.6. Tangent of pi over 4, I'm just going to add it. It's going to be root 2 over 2 over root 2 over 2, which is 1. And then tangent of pi over 3 is going to be root 3 over 2 over 1/2, which is going to be root 3, which is approximately 1.7. And then the tangent of pi over 2 we already did. We have found that it is undefined. So there obviously are some differences between sine and cosine and tangent. First of all, the symmetry for tangent is negative tangent at x, so it has origin symmetry and it's odd. So when it's odd, I just said it, we're going to reflect the points about the origin. So again, we're just developing a basic tangent graph right now, and you can see, just like all of our other graphs in math, once you have the parent graph, everything is just stretching, shrinking, raising, lowering, that kind of thing, and reflecting. So what I'm going to do right now is I'm actually going to put 0 right here. And the reason why I'm doing this is because it's symmetric about the origin. And I could show you how the tangent is odd. It has to do with the fact that if you do like a pi over 4 angle right here, you have root 2 over 2 over root 2 over 2. So the tangent of pi over 4 would be 1. And if I do the tangent of negative pi over 4, it's negative 1. So they're opposites, which means that it's odd and therefore symmetric about the origin. So we've done this a lot, so I'm not really going into detail on it. You can look at the sine or cosine video because I go over it again there. The reason why we want to know that it has symmetry with respect to the origin is so that we don't have to do a full trip of unit circle angles right here. We can use some points to reflect. So we know that the tangent of 0 is 0. That's right here. And we know that right here, and you're like, why is she putting pi over 2 there? I'll talk about it in a second. It's undefined. And in math, the way we see undefined in a graph is either a hole or an asymptote, and holes are generated by canceling factors. We don't have canceling factors, so it's an asymptote. If that's pi over 2, then this is pi over 4, and we actually have pi over 4 right there, and we know that it's 1. So I'm going to make this line a 1. Whoops. And there's a point right there. So far we have 1, 2 points and an asymptote. Well, the really cool thing about symmetry is that you can use symmetry to reflect. So this point isn't going to reflect because it is on the origin, but this point right here is pi over 4 comma 1, which means because it's odd, you change x and y. So this point will also be on the graph. Negative pi over 4, negative 1. When we graph these, you don't have to label. I just wanted you to see that. And because there's an asymptote at pi over 2, guess what? There's an asymptote at negative pi over 2. So for our tangent graph, we are going to always have 5 things, just like we had for sine and cosine. And those 5 things, you're going to have the point in the middle right there. And then you're going to have, you know, the asymptotes right here, which if you start with one asymptote and then count out 1, 2, 3, 4, that's where your other asymptote will be. Then you have these 2 points right here. You have this one, which if you look is the negative amplitude, because the amplitude up here is 1, and that's the negative amplitude. And then this point right here, 3/4 of the way, so this negative amplitude was 1/4 of the way. Halfway in between is an x-intercept, and 3/4 of the way, so 1, 2, 3 is the positive amplitude. And we'll go over that in just a second. Okay, so let's take a look at the properties of our parent graph. The domain is not all real numbers because we didn't even we have these asymptotes here. So I just wanted to point out that I haven't actually connected the dots, so that's what we're going to do. The tangent graph kind of takes this curve. So remember, it likes to coast along its asymptotes right there. So the domain, this is kind of weird to write because you're like, well, it can't equal these asymptotes, so how do we write that? So we say x such that x cannot equal the odd multiples of pi over 2. So there's not really a way to write this in interval notation because you have so many different asymptotes, because the graph goes on forever, except for there are certain excluded members of the domain, which are these asymptotes. And the reason why we say odd multiples of pi over 2 is because this is 1 pi over 2 right here. My next asymptote would actually be way over here. If this is 1 pi over 2, this one, so actually I'll do it this way. This is 1/4, this is 2/4, this is 3/4. This would be 4/4, which reduces to pi. This would be 5/4. And then this would be 6/4, which is 3 pi over 2. And as you can see, this was a 1 and this is a 3. So those are odd multiples. And this graph is just going to repeat itself exactly the same way that it did. So let me just make this clear. 1/4 of the way, if there's no reflection, it'll be at its negative amplitude. Halfway in between is always the x-intercept, and then 3/4 of the way is the positive amplitude. What is the range? These graphs go from negative infinity to infinity. So sine and cosine went from -1 to 1, but the range here is from negative infinity to infinity. Here's the other really big difference with tangent. Tangent's period is only pi. So if you look, the distance between negative pi over 2 to pi over 2 is only 1 pi. So tangent repeats after 1 pi. So really, if you're looking on this in terms of the unit circle, tangent's period, or its number, the rotation, it only takes it to go through pi before it starts repeating its pattern. So here in quadrant 1, tangent is positive, and then quadrant 2, it's negative, and then it's positive, and then negative. So it only takes pi, which is a huge difference. So you have to be aware of that. So This is pi divided by the absolute value of 1. B is still the number b for x. And in our equation up here, the number b for x is 1. So this is pi. Remember, sine and cosine is 2 pi. It takes sine and cosine a little bit longer, twice as long to be exact, to complete one full rotation. Vertical asymptotes are at the odd multiples of pi over 2. The x-intercepts are halfway between the asymptotes. And we already talked about this is an odd graph, so it has origin symmetry. And the last bullet point that I want to put on here for you is how to get those two other points. So we're just going to add it in there. Other points. And that is 1/4 of the way. We have 1/4 between the asymptotes. We have the negative amplitude. And 1/4, or 3/4, I should say, between the asymptotes. We have the positive amplitude. So I'm just going to highlight some of these things to tie it to the graph here. So first of all, the vertical asymptotes are at the odd multiples of pi over 2. Okay, so that's what's highlighted in pink in words and on the graph. The other points, so I have this point highlighted right here, that is the quarter way between the asymptotes, and it has a negative amplitude. And then the other one is this blue point right here, and it's here's 0, 1, 2, 3, 3/4 of the way between the asymptotes. That one is got a positive amplitude. Okay, so that looks like a lot to take in, and you're like, oh my gosh, do I have to do this for every graph? No, that's our basis. That's where we start from. If we can't figure out how to graph, we can always fall back to a table. What we're going to do right now is take a look at this right here, which are the steps to graphing when it's not the parent graph. Okay, so if you ever get stuck, just come back to these steps. A lot of times students get to the problem and they're like, I have no idea where to start. This is where you start. So the first step is going to be to find your asymptotes. Why do we want to find our asymptotes? Well, if you notice, the 3 other points that we have are going to be halfway between the asymptotes, 1/4 of the way, and 3/4 of the way. So guess what? Those asymptotes are super important. I'm just going to highlight this in orange right here because this is the orange point halfway between the asymptotes. Okay, so those asymptotes are really the clincher. Now you remember with sine and cosine, we looked at, did it go x-intercept max, x-intercept min, x-intercept, which is a sine graph, or is it going and starting with the max, x-intercept min, x-intercept max, which is a cosine graph. So starting at 0 is not always going to be the game plan for tangent, because you can see from its parent graph, it doesn't always work that way. So our first step is to find those asymptotes, and because the parent graph has asymptotes starting at negative pi over 2 and pi over 2, the way we're going to find any asymptote of a tangent graph is by setting whatever's in with the x equal to negative pi over 2 and pi over 2. And again, this is because these asymptotes are right here, and whatever's in with the x is going to stretch or shrink and shift right or left. So that's why we're setting whatever's in with the x. If you look at our parent equation right here, bx minus c is going to affect the x, so we're going to set that equal to negative pi over 2 and pi over 2. When we did sine and cosine phase shift, we took this and set that equal to 0, which makes sense because both of those graphs start at x equals 0. That's our starting point for those. But for tangent, our asymptotes don't start at 0. They start here. So that's why we're changing it a little. So we're going to go ahead and do that part for this graph right here. It says graph y equals 3 tangent to x. So before we get to doing that, we're going to start how we used to start, and that is finding the amplitude, which is the absolute value of 3. So that is 3. and then we're going to find the period. Here's that tricky part. The period isn't 2 pi anymore. It's pi divided by the number before x, which is 2, so our period is pi over 2. Now think about this. On tangent, just the plain old parent tangent graph, the period is pi. So this one has actually been shrunk down. You're not going to see it in our graph necessarily because our graph is going to be scaled. So the asymptotes are going to be 2x equals negative pi over 2. This is following the steps. And 2x equals positive pi over 2. Then I'm going to multiply by 1/2. You could also divide by 2, but I find it much easier just to multiply by 1/2 because it's the same thing. And I get one asymptote is at negative pi over 4. And same thing over here, multiply by 1/2, and I get the other asymptote is x equals pi over 4. This will not always be the case. They won't always be exact opposites of each other, so you always have to do the math for both. We are going to just cut these steps out right here because we don't need to write it down in a table to be able to figure out what to do. So this is how you graph from there. Ready? You go to your first line and you make that your smallest asymptote. So in that case, it's going to be negative pi over 4. You're going to count out 1, 2, 3, 4. Put your other asymptote. This is pi over 4. You're going to look at your scale and go, where does 0 belong? Well, in this case, 0 is going to belong right in the middle. Okay? Then you're going to do the points. This is a step 2. The x-intercept occurs midway between the asymptotes. So right in the middle is here at 0. So it's going to go here. Now we got to do 1/4 and 3/4 of the way, which means that this would be pi over 8. And this would be negative pi over 8. Our amplitude is 3, so the 1/4 of the way would be at negative 3, which I'm going to label. And the positive is going to be 3/4 of the way at positive 3. So it's right there. So it looks like that. Okay? Now, if you notice at the beginning of the problem, it said that it wanted you to graph it from negative pi over 4 to 3 pi over 4, and we're only at pi over 4 if you look at our graph. So we need to graph more of this. So the way that you do this is you just keep adding your scales. So pi over 8, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, and then 6 pi over 8. And you'll notice that for 4 pi over 8, I changed it to pi over 2 because it reduces, and 6 pi over 8, I also changed it. And what you really now see is that stipulation was asking you to actually graph 2 rotations. So midway between the asymptotes is the x-intercept. 1/4 of the way is the negative amplitude. 1/4 of the way is the positive amplitude. And there we go. Now I do want to show you something really cool, which is why does this point equal the amplitude? So watch. If I take that and I plug it in, so I'm going to take the pi over 8 and plug it in to my graph, to my equation, and then 2 pi over 8 simplifies to pi over 4. The tangent of pi over 4 simplifies to 1, and that's 3. So whenever we pick an angle, that's 3/4 of the way between the asymptotes, or even 1/4, this will end up being negative. What happens is it gives us the tangent when it's simplified, the tangent of pi over 4, which is going to give us 1. So we're just taking our amplitude and multiplying it by that number. Alrighty, so that was the explanation for the first one. Let's go ahead and see how this even goes faster once you get the hang of it. So the tangent of x plus pi over 4. So we want our amplitude, absolute value of 1, and our period, which is pi. Did you see I almost wrote 2 pi? It's pi. Pi divided by the number before x, which is still 1. so it's pi. So that's how long it goes through one full rotation. We need to find our asymptotes. So where are the starting asymptotes of this parent graph? At negative pi over 2 and pi over 2. Now we have to get some common denominators here because I'm going to do negative pi over 2 and I'm going to subtract pi over 4. So this is going to be times 2 and times 2, so I get negative 2 pi over 4 minus pi over 4, which means it's at negative 3 pi over 4. Again, this does not automatically mean that this is at pi over 4, okay? So I have to do the math. So pi over 2 minus pi over 4, which gives me 2 pi over 4 minus pi over 4, which is just 1 pi over 4. Okay, so there's my two asymptotes. We're not going to be doing these. And this does say graph 2 full periods. I think we'll be fine if we just graph 1. Okay, so what did we say? You go to your very first asymptote, or your very first line, and mark your smallest asymptote, which is negative 3 pi over 4. And then you count out 1, 2, 3, 4. Mark your next one, which is pi over 4. Where does 0 go? So 0, negative 3 pi over 4 to pi over 4. Where would 0 be? Well, think of it like as between negative 3 and 1. So 0 is much closer to positive 1. So it would go here. This would be negative pi over 4. So 1/4, 2/4, or negative pi over 2 would be here. Okay? And then it's the same old, same old. It's so nice because these are scaled. 1/4 of the way we go negative amplitude. Halfway in between is positive amplitude. And then 3/4 is, halfway in between is the x-intercept, and 3/4 of the way is the positive amplitude. So I'm going to label that 1, and that labeled negative 1, and then it goes like that. Okay, so that is tangent. We're going to flip over to the back side and talk about cotangent, kind of just see what that graph would look like, and just talk about the differences between tangent and cotangent. All right, so here's the general equation for cotangent. So it's right here, but then you go, it's very similar to graphing tangent, except for this right here. It says your asymptotes are not at negative pi over 2 and pi over 2, they're at 0 and pi. What the heck? Why would this be? So we're going to take a look, just do a quick comparison here between y equals tangent x and y equals cotangent x. The ratio for tangent of x is y over x, and the ratio for cotangent is x over y. So if I'm on the unit circle, and let's get those 4 points on there that are our quadrantals, because they'll be enough to show us y. We get the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so we're there. Look at when I do y over x. When I do the tangent of 0, y over x is 0 over 1, which is 0. Over here, though, when I do the cotangent of 0, it's x over y, which is 1 over 0, which is undefined. Where do asymptotes go? Asymptotes go where you're undefined. So at an angle of 0, cotangent is undefined, but at an angle of 0, tangent is not. It's 0. So let's go to pi over 2 and see what happens. At pi over 2, y over x is 1 over 0, which is undefined. Hey, we have an asymptote for pi over 2 for tangent. Over here, the cotangent of pi over 2 is 0 over 1, which is 0. So no asymptote at pi over 2 for cotangent. What about the tangent of pi? Well, that's going to be 0 over negative 1, which is 0. What about cotangent of pi? Which would be negative 1 over 0, which is again undefined. So you can see this is where our asymptotes are. Now for tangent, we had one at pi over 2 and negative pi over 2. So just think if we went in that direction and did the tangent of negative pi over 2, that's going to be this point right here, which is going to be y over x, which is undefined. Okay? So remember, negative pi over 2 and 3 pi over 2 are coterminal angles, but do you see these undefined? That's where our asymptotes are. So it makes complete sense that tangent and cotangent aren't having similar, they don't have the same asymptotes because they're not undefined at the same place because they're different ratios. Okay? So that was long just to get that concept down. So you need to know that right there. That's so important. Those are the two things. That's one thing I should say that's different. The x-intercept is still in the middle, and here's the other part that's different is that 1/4 of the way with cotangent, you're actually going to be at the positive amplitude, and at 3/4 of the way, you're going to be at the negative amplitude. So it flip-flops, right? So same thing, find your asymptotes. Mark the x-intercept in the middle. With cotangent, you're going to start high at the positive amplitude and then 3/4 of the way go to the negative amplitude, and vice versa for tangent. So let's go ahead and start with our amplitude and period. So this is just 1/2. And the period, guess what? Just like tangent, it's pi over b. So we're going to do pi over 2, which equals pi times, copy dot flip, 2 over pi, whoa, which is just 2. No pi on that, just 2. Why? Because the pi's canceled out. Okay, so it's going to have a distance of 2. We'll just confirm this with our graph, and the way we're going to do that is by finding our asymptotes. So with cotangent, to find our asymptotes, we set whatever's in with the x, pi over 2x equals 0, and pi over 2x equals pi. Okay? And then I'm going to multiply this by its reciprocal to undo it. And anything times 0 is 0. So my smallest asymptote is at 0. It's nice because you don't have to deal with negatives very often unless, with cotangent. So this one I get 2. Now look at the distance between my asymptotes. It's a distance of 2, which is confirmed by me seeing that I already calculated the period was 2. So you're going to go to your first mark it 0, which is also the y-axis, and count out 1, 2, 3, 4. Asymptote, it's going to be 2. Halfway in between is my x-intercept. I'm going to label this 1 and -1 so that I can do my my additional points. Now I'm also going to label. If you want to label in decimals, that's fine. 1/4 of the way, I'm at the positive amplitude, and 3/4 of the way, I'm at the negative amplitude. Okay, so it looks very similar, and in fact, if I were to reflect this graph, it would actually look like a tangent graph. You will have some in your homework where you're reflecting, but just keep that in mind. If it looks like a tangent graph, and you just check to see if there was a reflection, and if there was at least a reflection in the x-axis, and in the y for that matter, it would look like a tangent graph. So that's the lesson, but I am going to share with you something really cheesy. Obviously, students have had a hard time remembering that tangent goes with negative pi over 2, and cotangent goes with 0 and pi. So this is something that a student came up with, and I figure, you know what, why not share it? Because if anybody can get help from it, then that would be great. So tangent, somebody said, well, if you're getting a tan, like tangent, I know we're being silly, your day is going up. So that's why you're going to go from low to high. So negative amplitude to positive amplitude. And if you're getting a tan, you're looking good. So you should only eat half a pie instead of the whole pie, because then you might not look so good, I guess. So that is like pi over 2. You should only eat half a pie over 2. But tanning could be negative because you could get skin cancer, so it could also be negative pi over 2. It's a bit of a stretch, but maybe it can help you. And of course, so this is all helping us remember the asymptotes for tangent and from negative pi over 2 to pi over 2. Here is cotangent. So cotangent, you can see that looks like cot. We don't pronounce it cot ever, but okay, for the sake of the analogy, we'll do it. If you're sleeping on a cot, your day is going downhill. So from left to right, you're going down. So you started with a positive amplitude and then you went to a negative amplitude. If you're sleeping on a cot, you have $0 to buy pi. So your asymptotes are from 0 to pi. I don't know. Just something to help you out. Alrighty. Have a great day.